Hi everyone, so today we'll be solving initial value problem defined by d square by dt square plus n square into x of t is equals to a sine of nt plus alpha semicolon, where x of 0 is equals to x dash of 0, which is equals to 0. So now we have d square by dt square plus n square into x of t is equals to a into sine of nt plus alpha semicolon x of 0 and x dash of 0 both are 0. So these are the conditions given. So now take this and apply Laplace transform on both sides of the given ordinary differential equation under the initial conditions. So on applying Laplace transform, we get Laplace transform of d square of x of t divided by dt square plus n square of L of x of t is equals to a into L of sine nt plus alpha. Laplace transform of d square of x of t by dt square is p square of L of x of t minus p into x of 0 minus x dash of 0. So we have x of 0 and x dash of 0 as 0. So these two terms will not be there and this will be remained with, plus n square into L of x of t same is equals to a into L of sine nt plus alpha. So sine of a plus b, so this you can write it as sine a cos b plus cos a sine b. So writing sine a cos b plus cos a sine b, that is sine nt cos alpha plus cos nt sine alpha. So p square into x of x bar of p, this is a Laplace transform of x of t is x bar of p plus n square of L of x of t, that is x bar of p, is equals to a into L of sine nt cos alpha plus cos nt sine alpha, which is equals to a into L of sine nt. We will consider the terms only with t, and cos alpha will be constant, so it will be out, plus a into L of cos nt into sine alpha. So which is equals to, now you can take p square and n square common. So p square plus n square into x bar of p, which is equals to a into L of sine nt, Laplace transform of sine nt into cos alpha. So Laplace transform of sine nt is n divided by p square plus n square. Cos alpha is constant, plus a into sine alpha is constant again. Laplace transform of cos nt is p divided by p square plus n square. So x bar of p is equals to a into n cos alpha into 1 by p square plus n square whole square plus a sine alpha into p divided by p square plus n square whole square. So now as you can see this and this. So we want to take out the inverse of Laplace transform. We want the inverse of this, because this will be constant, this will be constant. We only want the inverse of this and this in order to get the value of x of t. So L inverse of this will take first, p divided by p square plus n square whole square, which is equals to which is equals to, as you can see, I'm just writing n in the numerator as well as denominator. So if you see it carefully, it is if you multiply with 2 on here, it will become the derivative of 1 by p square plus n square. Okay, so if you see that way, it will become derivative. So we are writing in such a way that it should be related with this. So on writing that way, minus 1 by 2n will get into L inverse of minus d by dp of n divided by p square plus n square. So now here this, it resembles the formula of t into f of t. So minus 1 by 2 n t into f of t is sine nt. So t into sine nt, this is the Laplace. So if you consider this, it will show you that Laplace transform of sine nt. So t into sine nt divided by 2n. So here we have given the reason, since Laplace transform of t into f of t is equals to minus d by dp of f bar of p. Therefore, since integral over 0 to t f of t dt is equals to Laplace inverse of 1 by p into f bar of p. So this is the reason. So now this is the reason for the second one. So let's check the second one. We did this, we want this. So for the second one, Laplace inverse of 1 by p square plus n square whole square, which is Laplace inverse of, if you take 1 by p of this Laplace inverse, so you'll get this value, that is Laplace inverse of 1 by p square plus n square whole square. So pp gets cancelled, will be remain with same. So we are doing this way. So we have the formula, that is integral over 0 to t f of t dt is equals to L inverse of 1 by p into f bar of p. So if you see here, you'll get Laplace inverse of 1 by p into p divided by p square plus n square whole square. It can be written as integral over 0 to t into f of t dt, f of t. So here f of t will be our t sin t, t sin and t divided by 2n, this it will be. So integral over 0 to t, t sin n t dt divided by 2n. Here 2n will be constant, it will be out. So integral over 0 to t, t into sin n t dt. Now you are applying Eilert rule and you are integrating it. So t becomes the first function and sin n t becomes the second function. First function into integral of second function minus integral over derivative of first function into integral of second function, and then applying the limits. It is from 0 to t. So is equals to 1 by 2n into minus t cos n t divided by n plus sin n t divided by n square. So when you integrate this, you will get in the denominator as n minus n as coefficient. So minus n into n square, minus of minus plus. So just remove this n outside and write it as n cube n square outside, and write it as minus nt cos nt sin nt. By taking common, you will get 1 by 2n cube into sin nt minus t minus nt cos nt. So our Laplace inverse of 1 by p square plus n square is equals to 1 by 2n cube into sin nt minus nt cos nt. So then we are just substituting the value of this Laplace inverse of 1 by p square plus n square and Laplace inverse of 1 p by p square plus n square whole square in the given formula that we got over here. X bar of p is as this now. So x of t will be this into Laplace inverse of this plus this into Laplace inverse of this. So that is Laplace inverse of that values we are substituting over here, thereby resulting we are getting x of t is equals to a into n cos alpha of 1 by 2n square into sin nt minus nt cos nt plus a into sin alpha t divided by 2n sin nt. So this is how we'll be able to find the solution to the initial value problem. Thanks for watching. If you have any doubts, please do comment.